This is 500 million needles in space. For a moment, Earth looked like Saturn. This was no sci-fi movie. It was a real Cold War experiment, a top-secret mission to build an artificial ionosphere and save America's global communications. It was called Project Westford, and today, its strange legacy still orbits above us. It's 1961. The Cold War is in full swing, and US military planners face a terrifying scenario. What if Soviet saboteurs cut the undersea cables linking America to its forces abroad? The fallback has always been to bounce radio waves off Earth's ionosphere, a region above the Earth's atmosphere. But that layer of charged gas is fickle. Solar storms and the sun's cycle often disrupt it. Cutting the cables would throw global communications into chaos. The solution? An audacious idea born at MIT's Lincoln Laboratory. Don't trust nature. Build your own ionosphere. In 1958, engineer Walter E. Morrow and his team at Lincoln Lab proposed a wild scheme, originally called Project Needles. They would loft 480 million tiny copper dipole antennas into a polar orbit, forming a global spaceborne reflector. These needles were 1.78 centimeters or 0.7 inches long, half the wavelength of the 8 GHz radio signals that the experiment aimed to use for global communication. This Westford ring would act as a gigantic radio antenna, ensuring robust worldwide communications, even if undersea cables were cut or the ionosphere sputtered. Lincoln Lab even built a custom ground station for Project Westford, the Haystack Radio Telescope in Westford, Massachusetts. This 37-meter dish sits under a huge 46-meter dome, precisely to broadcast and receive the 8 GHz signals. On October 21, 1961, NASA blasted off the first Westford payload on an Atlas Agena rocket from Vandenberg AFB. Its carrier, Midas 4, was an early missile warning satellite sharing space with the needle dispenser, but the result was a flop. The dispersal mechanism jammed after reaching orbit, producing only a few tiny clumps of needles instead of a continuous belt. Soviet media promptly declared, USA dirty space. The MIT team regrouped and launched again on May 9, 1963. This time, the needles flew free. Over the next day, they were circling Earth. For a brief period, the experiment worked. Voice test calls were relayed from MIT's Haystack dish to camp parks in California by bouncing off the new copper belt. Engineers reported intelligible communications, roughly equivalent to 20,000 bits per second, like a 1990s dial-up modem. But the success was overshadowed by controversy. Scientists worldwide were alarmed. Radio astronomers howled that a cloud of copper dipoles could garble their observations. Optical astronomers worried the needles might glint in telescopes. Britain's top radio astronomer, Sir Bernard Lovell, warned that the real problem was the attitude of mind, a stealthy military experiment done without any international agreement. The International Astronomical Union condemned Project Westford, and public pressure grew. Pressure mounted in the UN. Ambassador Adlai Stevenson had to defend Westford by explaining that sunlight pressure would drag the tiny needles out of orbit within a few years. The uproar led to the 1967 Outer Space Treaty, requiring international consultation before polluting orbit. In effect, Project Westford's protest sparked the first rules of space debris diplomacy. Most needles burned up harmlessly, but a flaw meant some welded into clusters, and these clumps still orbit Earth today. NASA tracks more than 40 such clusters, though quickly replaced by communication satellites like Telstar 1. Westford's legacy remains a lesson in orbital pollution and Cold War desperation. It succeeded technically, for a moment making Earth look like Saturn, but its lasting impact was in the politics of space. That is the story of Project Westford, one of the boldest and strangest experiments of the Cold War.